Where? Cool. So let's do this last part, this last video. We're gonna do a couple of problems. Yeah, let's get started. So the first one, right now we are solving for x. Remember this chapter was equations and inequalities. So we are solving for x there. And what I would recommend you do is so first thing first, we have to transpose the 14x. The reason is, like, quite often when we factorize, this is the structure we want to have, especially when we are factorizing trinomials. Now when we are factorizing trinomials, this is the structure we must have. And the reason I am mentioning factorization under the topic of solving x is that here when we are solving for x, if we have a trinomial, or even, it doesn't matter whether we have a trinomial or a binomial. I think what matters the most is if you have a power of x, a power of 2. Now one of your variables, the word I've been looking for is quadratic. When you have a quadratic expression or equations, and you want to solve for x, you are going to factorize at some point. So this is the structure you have. And of course, when dealing with factorization, I said myself, as soon as I get a number that has a number that I have to factorize, and that number has a value, the x squared has a coefficient, I cannot do my two brackets and immediately write numbers there. I can't do that. So what really helps me is the step that I gave you as well, that the first thing first, you focus on the coefficients. That and that, we multiply the numbers together, we're getting it's 15 times 8, we are getting 120. So 15 times 8 equals to 120. Then we look for factors of 120. That gives us, then now we focus here, factors of 120, that gives us 14 when we add or subtract. So we are looking for a pair, right? Cool, let's get started. So we have 1 and 120, 2 and that will be 60, 3 that will be 40, and then we have 4 and 4, that will be 30. Let me see. No. Then 5, it has to be 24. Nice. 5, 24, 6. So we haven't got a pair that gives us 14 when you add or subtract, right? So now it's 20, and I will stop here because this is the factor, or this is the pair that gives us, right, the middle number. Look at this. No. 6 minus 20. How much am I gonna get? I'm gonna get minus 14, which is really beautiful, man. So cool stuff. Okay. Cool. I shouldn't have deleted this, but it's fine. I'll note it down here. We said 6 minus 20 equals to 14 minus 14. So that being said, we're gonna use this number 6 and 20 right here in the middle term. You have 15x squared plus 6x minus 20x minus 8 equals to 0, right? So now we're gonna group, but here we have a negative, of course, so you can do this 15x squared plus 6x, right? And then plus, then open bracket, then you write this minus 20x minus 8, 0, right? So now this is where we take out highest common factor in each bracket. So here we're gonna have the highest common factor as what? I think There's of course there's x and 3 as well, so we take out 3x, and this is gonna be 5x plus 2, yes, plus 2, and then here we take out the negative value of 4. 4 is the highest common number, so 4, then you have 5x plus 20 plus 2 highest common factor 5x plus 2, 3x minus 4. This is where we get to the conclusion. We can say therefore 5x plus 2 equals to 0, or 3x minus 4 equals to 0. 5x equals to minus 2, 3x equals to 4, therefore 4 over 3, therefore x equals to minus 2 over 5. Right, we can actually test it. We can test these two values. Let me test it in this way and say I have 15x squared minus 14x squared. I want them to give me 8. No? I want them to give me 8, so I have 15 squared minus 14, right? So let's start with we have 4 over 3 here. Yeah, that's 14. I said 4 over 3. Close it. 4 over 3, and we are getting 8. Ne? How about the other one? So we try 5, we try minus 2, minus minus 2, 5, and we are getting 8. Ne? So that was perfect. Don't forget that. Yeah, here's another one. It looks like we might even need more space here, but let's see what we have. Okay, we have plenty. We have so many numbers here. Ne? We have so many numbers, and yeah, we have so many numbers. Let's see how we're gonna approach this one. Cool. I'm thinking here, these brackets, ne? You can easily factorize them. Two numbers, you multiply or add. Okay, when we factorize this bracket, it's like this. So two numbers, you have x, and the reason we do it this way is because coefficient of x squared is 1. So two numbers you multiply, you get 6, you add or subtract, you get minus 5, that is minus 3, that is minus 2. Do you see? And now let's look at this. You have x minus 2, we can make this be x minus 2. You have x minus 3, we have x minus 3. So this it's a relief to me. Ne? It's a relief to me. So maybe for now we can focus on this side. Ne? If we focus on this side, I'm also seeing here we can say we have square root of 2 and then x squared minus 25, which becomes difference of two squares. But we'll see if we really have to do this. Now you might realize that we don't have to. So cool. So here we are multiplying these brackets. So there was a formula or a method that I taught you guys when you have fractions and you are adding or subtracting those fractions, and I said you have a over b minus c over d. I said one of the easiest way to get this done, you would say of course you multiply these two. That's the first thing. You have bd after multiplying both of them, and then the sign is negative, so you will have negative, and then you cross multiply, so you will have ad. You cross multiply, you will have bc. That's how it works, and that's what we're going to use. I mean, you can still use other methods, they will get you to the same answer, but this one is quicker. Ne? So let's start. We'll start with the denominator. You multiply these two. In fact, before we multiply, because just want to make it a little bit interesting. Before you multiply, let's say you have x minus 3, and then minus, ne, open bracket, x, ne, and then minus x minus 2. Do you see what I did? Ne? This minus 1 here gonna, yes. So there on the numerator, I don't know if we will have to factorize yet or not, so I'm just gonna leave it as it is. Ne? I'm just gonna leave it as it is. Okay, cool. 5x plus 6. So now I know that I have x minus 3. I have a plus x over x minus 2x squared minus 25 over x squared minus 5x plus 6. Hope that's not messy. So multiplication now. So we multiply these two. Let's start with the denominators. We multiply these two. You have a bracket of x minus 3, x minus 2, né? And then it's this times that you have x. I don't know if I should. Let me just multiply them. So it's gonna be x squared. It's gonna be minus 2x, né? And then here it's gonna be plus x squared minus 3x. So let me see, x squared minus 2x, x squared minus 3x. That is fine. So here 2x squared minus 25 over this we can factorize, and remember we said it's x minus 3. Oh no. Yeah, hey. No. Okay, it's fine. Oh my. Okay. Okay. So I'm realizing that I made a mistake. It was a very, you see these mistakes, man. It was a very, very easy mistake that I made when I was talking about the factorizing this. I had x minus 3 and then I had x plus 2, right? I don't know if I did it the right way, because actually here both of these are going to have to be minus, so that you multiply minus 3 and minus 2, that is 6, which we have here, and then you add the 2, they give you minus 5. I don't know. I hope I didn't mess it up. I hope, but something is telling me that I did. Yeah, apologies for that. Yeah. But yeah, let's continue. We don't have time to edit. Damn. Damn. I bet. It's fine. Cool. So this is what we have now, and the next step, I am going to destroy these denominators because they are all the same. So if on everything I multiply by what? I multiply by x minus 3, x minus 2, right? If I multiply everything by that, I'm gonna end up with, let me add these two. So I have 2x squared, I have minus 5x is going to be equals to 2x squared minus 25. Right, that's what I'm gonna have. Yes. So these 2x squared, they will subtract each other and the answer will be 0. So let's so I'm gonna have something like this. I'm gonna have, perhaps let me do this. So this is gonna be 0, of course. Let me say I have 0 and then I have 5x minus 25. And then I continue. So 5x, or maybe I can say 5 into x minus 5 equals to 0, and then x equals to 5. So let's see, let's test it out. So you have 5 minus 3, it's a minus 5, 2 minus 5. Look, we are getting this fraction. We are getting 25 over 6. Let's jump on to the next fraction to see. So you have 2 multiplied by 5, 5 squared minus 25, and then we have 5 squared minus 5 times 5 plus 6, ne? And we are getting 25 over 6. We are still good. Yeah, I hope I didn't do that mistake, bro. But yeah. If you stayed with me, you saw the real thing, man. You saw the real thing. Let's continue. Simultaneous equations. But so simultaneous equations, remember, you identify your equations. That's the first thing. You have 2x minus 4y equals to 6. That is equation 1. You have 3x minus 5y equals to 10, right? 2. Cool. So remember, there were how many methods did we do? We did substitution and elimination, right? So I'm gonna try one method. Perhaps maybe let me see what questions I have next. It looks like I have another simultaneous. Cool. I bet. So what I'm gonna do is I'm gonna use different methods for these formulas. I don't know, maybe should I do 2 methods? No. Okay, so I'm gonna use elimination method. But for those who want to try substitution method, I want to show you something that will make your life easier. Here you can say you have 2 into x minus 2y equals to 3, right? Okay. Equals to, yes, it equals to yeah, equals to, okay, it's this, equals to 2 times 3, ne? And then these two, they're gonna cancel out each other when you divide. Then you have something like this, ne? You have something like this, and then from this you then say that minus 2a, you're gonna say equals to 2y plus 3, right? And then you use this for substitution to say substitute this x into this equation, and then you go on. It's gonna be very easy. So that's just the truth, but I'm gonna use elimination method. So for elimination method, I can decide which variable do I want to eliminate. Let me eliminate x, né? And for me to eliminate x, remember, my x variables, they must both have the same coefficient with different signs. So so how am I going to achieve that with this one, eh? So I'm going to, the first thing, I can multiply here by 3, say multiply by, let me go minus 3, and then here I can multiply by 2. Therefore, right, therefore you have minus 6x minus plus 12y equals to minus 18. And this is equation, let's go again and say this is equation 1. And then we go again, we have 6x minus 10y equals to 20. This is equation 2. Now we add, né? So equation 1 plus equation 2, right? So I have minus 6x plus 12y minus 18 plus 6x minus 10y equals to 20. 0 here, wait, was it 12? Yes, it was 12 minus, yes. So this together, that is 2y equals to this together, that is what? That is, come on, think Buddha 2, right? Oh, I forgot the plus here. So therefore we are getting that 2y equals to 2, therefore y equals to 1, right? From getting y being 1, you can go to any of those equations, say perhaps 2x, so you go 2x minus 4 y equals to 6, 2x equals to 4 into 1, 4 into 1 plus 6, 2x, that is 10, x equals to 5. So therefore you would say that you will then say you have 5 and 1, right, as your coordinates. Yeah. But because of that mistake that I did, I just want to quickly. I know the equation I had was x equals to 2y plus 3. So if I substitute it here, I'm gonna have 6y plus 9 minus 5y equals to 10, and then this gives me y, and then 10 minus 9 equals to 1. Cool. I just wanted to make sure. So everything is fine. I was just trying a substitution method there to see if we have the same value. So when we do, right? So here, let me do this. We're gonna use substitution method for this one. So you have, let me write. You see this, Let me use a different color maybe. You see this? I will say A equals to 12 minus B, and that's equation 1. Then 4A plus 2B, 44. That is equation 2, right? And now I'm substituting sub equation 1 into equation 2. If I do that, I have 4 into 12 minus b plus 2b equals to 44. Right, 2b, yes. I do my math, that is 48 minus 4b plus 2b equals to 44. Alright, let me transpose 44, so I have 48 minus 44. This 2, it's minus 2, or let me just say 4b minus 2b. Then you have 2b. Here you have 4. Let's see. Yes, you have 4. Therefore, b equals to 2. Right. After getting b, we therefore a equals to remember 12 minus b, which is 12 minus 2, which is 10. That was fast. You see, alright. Now I'm gonna erase this. We have a weight problem. Cool. So we have a weight problem. Let's get it done. Sipho is 7 times. Sipho is 7 times older than his son. I bet. In 25 years' time, he will be twice as old as his own son. By formulation, solve an equation in X, calculating his son's present age. Wow. Okay. So here, let's think. I'm gonna say Y. This is who? Sipho. This is Sipho. Sipho's age. And I'm gonna say X. Son's age. And I'm talking about present age, because yeah, it's their present age. So now they're saying that currently, Sipho is 7 times older than his son right now, right? Therefore, y is equals to 7 multiplied by 7. 7 multiplied by x. Yeah, 7 multiplied by x, which is 7x. This is what's happening right now. And then look at this. In 25 years' time. So this is the current situation. In 25. Okay. In 25 years' time, he will be twice as old as his own son. Yeah, so now let's find a way to actually how do we put that into an equation? It's a very tricky one. So in 25 years from now, implying what did we do? We added 25 years to their ages. So here's an example. Okay. Here's a very good example. So in 25 years time, there will be both of them, they will be 25 years older than right now. Yeah, in 25 years time, both of them, they will be 25 years older than right now. So now what I'm gonna do is, in 25 years time, we're gonna have what? We're gonna have this side, we're gonna have y plus 25. Because this y plus 25, this is Sipho's age in 25 years time. Now let's focus on the son. The son in 25 years time, he will be how old he is right now plus 25. But it's not only that. Now they say in 25 years time, he will be twice as old as his son, right? So we're talking about Sipho. To say Sipho, he will be twice as old as his son. So meaning Sipho's age in 25 years time, it will be twice her son's age in 25 years time. So then we put 2 here. Yeah. So I hope it makes sense. From now on, let's go on and simplify this equation. You have y, and maybe let me continue with this one. Y plus 25 equals to 2x, 2x plus 50. Now I can substitute. I mean, when you are writing on paper, guys, do that structure and substitute. Yeah, for me, I'm just gonna substitute right here. Right, therefore I have 7x plus 25 equals to 2x plus 20 plus 50. This is 2x. I transpose 2x, we have 7x minus 2x. I transpose 25, we have 50 minus 25, we have 25. Come on, bro. 5x. Then you have divide by 5. You have x 5. Right now the son is 5 years old. So let's do the math now, just to see if it makes sense. We're gonna do the math right now. This is the son and this is the father. Hey, I wonder why they're not calling Sipho the father. Is it maybe it's not the father? But okay, the son right now is 5 years old. The father Sipho is this much old. And that is 35. Right, so in 25 years now it's gonna be 25 plus 35, 25 plus 35. This is our old, I believe this is 70. We will check. This is 35. Let's check. 25 plus 35. Yay! 25. Ooh! Okay. 25 plus 35. The answer is 60. And here, I must always use the calculator. It's not even the calculator. It's yeah. In 25 years time, so 25 years later, right? And I'm getting, this will be just 30. And yes, we are right. This is 30. And yes, we are right, because now double this, you get this. Half of this is this. So we are fine. So we have for okay. So for x if, né? Okay, cool. So this one just a simple math. You have, in fact, let me show you something. You have 3 into 2 minus 3x, né? I was tempted to actually multiply by 3 all over, and then I remembered that 15 can be written as 3 multiplied by 5, of which in this case, okay, we divide by 3, and then the 3, they divide each other, and then you have 2 minus 3x greater than or equals to 5. You have 3 minus 3x greater than or equals to 5 minus 2, and then minus 3x greater than or equals to, that is 3. We divide by minus 3, and therefore x, remember the sign, it changes, and then you have minus 1, right? So these people, they are saying that if we substitute any value equals to or smaller than minus 1, we're gonna get a value greater than 15, right? Let's put it to a test. You have 3, right? You have 3, and then you have 2 minus 3 into what? Let's start with minus 1. Minus 1, we get 15. Because there's an equal sign, it is fine, right? Let's go. Increase the number. Do you know what I mean? So any number below, below or smaller than, any number equals to or below minus 1 works, right? And of course, as soon as you substitute a number that is greater than minus 1, you're gonna get minus, right? Even if it's minus 0.99999, right? Let's see, we are getting 14.999, not exactly, you know what I mean? So yeah. So to represent it in a number line, you will then say this is a number line, right? And then you have 0, minus 1, right? Negative infinity, positive infinity. Your thing goes from here, and we are going this direction. And because there's an inclusion sign, to say equals, or there's an equal sign, you're gonna make it a dot instead of a circle, right? And just like that, brother, you are done. Let's see what we have here. Alright, but these are the last pairs. So solving the inequality again, of course, you know the drill. You're gonna transpose 3, so you have minus 3 minus x over 2, right? Minus 2. And then the next thing, let's multiply by negative 2. We'll multiply by negative 2. You're gonna have a positive 6, the sign changes. You're gonna have a positive x, the sign changes. You're gonna have a negative 4, right? Which you can simply write as minus 4 x 6, right? These two things, they're the same thing, right? They're the same thing. And yeah, just like that, for you done. And let me see, write down an integer that makes the equation invalid. So write down an integer that makes this this inequality invalid, ne? So that integer, it's gonna be anything, ne? Okay, let me say it. Anything that is below, wait, anything that is equals to or smaller than 4, minus 4, yeah, anything that is smaller than or equals to minus 4, and anything that is greater than or equals to 6, right? So in that way, you guys will choose. Now you can write 10, you can write minus 5, minus 5, you can write 4.5, minus 4.5, you know what I mean? Oh, but they said integers, so, yeah, so minus 10 million, right? So it's up to you. We have another word problem. Okay, let's see. Mary gave 1/3 of her money to Nazarene and 1/5 of her money to Elwetu. Elwetu receives 28 rand less than Nazarene. Yeah. Oh, it's not even Nazarene, I'm saying Nazim. Yeah, Nazim. I wonder if that's an English name or a Xhosa name. How much money did Mary have originally? Cool. So, of course, we can say X. So X, that is money given to Nazim, and then Y, that is money given to Elwetu. Alright, so cool stuff. Yeah, now let's read, let's hear what they're saying. Mary gave 1/3 of her money. I bet. I'm thinking now, like the way in which I named my variable doesn't necessarily make sense. I'm stuck between this. Do I make X to be the money for, because for here, what comes next is maybe I say Z equals to X plus Y, and Z is money for Mary. That's Z, that is Mary's money, right? But now, like when I read the question, that but bro, let me not confuse myself further. Let's continue with it like this, né? So they say this is the money given to Nazim. Yeah, this is the money given to Nazim, né? And let's see how much money was that. Mary gave 1/3, so 1/3 of her money, that is 1/3 of Z, to Nazarene. And then we say X equals to we say whoa. We say and 1/5 of her money to Elwetu. 1/5 Z to Elwetu. No, this is why. This is why for Elwetu. I'm just gonna say Elwetu at this point. So then they say Elwetu receives 28 rand less than I. So this is the money that she receives, né? Then I would say X minus Y equals to 28. Right, X being the money that who's receiving 28 rand less than, yeah, Elwetu is the one who's receiving the money that is short by 28 rand. So yeah, because Nazarene got happen to have had 28 rands more than Lwetu, right? So yeah, that is it. Ne? That is it. So now here's what I'm gonna do. Ne? Right here, instead of writing my x and y's, I'm gonna write 1 over 3z. No. Let's think about this one. So how do we solve this problem? How do I solve this problem? Bad. So bad. Bad. Equation 1, which is that. Equation 2. Equation 3. Equation 4. I'm going to try to use all of them. Yeah, I'm going to try to use. But I'm very sure there's a better way of actually naming your variables here. So I'll say from here, we have x equals to 28 plus y. Yeah. Yeah. And now I'm going to substitute my 28 in terms of z. So I'm going to have 1 over 3 z equals to 28 plus 1 over 5 z. Then this is more, so let's transpose. We have z, no, 1/3 z z 28, we say z 15, 5, 3. Z to 15, and then I'm going to try to multiply by 15 over 2. So the 2 will cancel, the 15 will cancel. So that means I have z, and then here $210. Whew, okay. I mean, I did get to the answer eventually. So let's test whether this is fine. It has to make sense. It has to make sense. So what is x? X is going to be it looks like I didn't use this equation. It looks like then this one was not necessary. Yes, probably. Yeah, it is. Cause yeah. No, I think this is wrong. Let me tell you why that is wrong. It is wrong because they didn't tell us that their money combined together, they add up, they give you or like they didn't actually say, and there was no implications of what I'm gonna say. They didn't say that Mary gave all her money to both of these parties. Yeah, so 1 over 3 into 210. It's 70 rand, ne? And then y it's 42, and then x minus y, which is 70 minus 42. So 70 minus 42. Right? So now everything makes sense. This is the 1/3 of 210, which is this. This is a 1/5 of 210, which is this. And the difference between their money, or we could say, yeah, the difference between their money is actually 28 rand. Or we could say, who's X? Let me see. X is, okay, Nazin. We can say Nazin had 28 rands more than Lwetu, and Lwetu had 28 rand less than Nazin. So that is it. So one thing from this question, this is wrong, because even here when we prove it, you add the 270 rand plus 42, it's not gonna give you, it's gonna give you 112. Let's test it. 70 plus 42 2. I bet that's it. Let's call it a day, close this chapter. Thank you so much, guys, for the support, and enjoy yourselves.